Okay, Vivi, we're going to talk about 2014 problem 3. Okay, now look on that piece of paper. What do you see?
See that?
Yeah, what is it? What kinds of shapes do you see?
I see a line, and a lot of arrows, and then numbers, like 1 and 2 and 5, and a 0.
Mm-hmm. Oh, okay.
And more arrows.
2014 problem 3, this is A, B, and BC shared. You're given the function f defined on the closed interval. This is a graph of f. Let g be the function defined by g equals the integral of f. So it's important to note right away that g prime is f. You might even note this for yourself right there, and I'll be writing that repeatedly in the problem. For part A, find g of 3. G of 3 is gotten by plugging 3 into the expression for g. At this point, you need to find the value of that integral, and that'll be done by area. Okay, so the idea is to find the area of each triangle, you use 1/2 base times height. For right now, I'm assuming 2 is a height, but I'm going to need to actually count and confirm that. So this is the point 0, 4. I see a drop from 4 to -4 of 8 units, and then an increase in x of 4 units, so that's a slope of -8 over 4, which is -2, which confirms my thought that this will have a length of 2. I didn't have to find 9, but in this case I've done the problem ahead of time. I know that I need to do that for a later problem. In real time you would probably just stop with this expression and then come back and get this if you needed it. Part B, on what open intervals contained in the whole thing, but open, is the graph of g both increasing and concave down? Give a reason for your answer. So g is increasing. And then g is concave down. Okay, so it's important in both of these cases to note that g prime is f and g double prime is f prime. This is how you accumulate points in these sorts of problems. You need to show knowledge of calculus. So at this point you just look at the curve and figure it out. So g prime just is the value of f, and f is positive whenever we're above the axis. So those will be my possibilities. Okay, and then g double prime is f prime, so we're looking at slopes of f, and it looks to me like the slopes are negative on this first interval and then this last interval. So those will be my answers. Okay, part C, the function h is defined by h equals g over 5x. Find h prime of 3. So first of all, I just need h prime of x at all, and that's a quotient rule situation. Now I just plug in. The reason I know this is because I know that g prime is f, and f of 3 is -2. I can see it on the picture. I've already had to use that dot right here in an earlier part of the problem. And the reason I know to put the 9 here is because I imported that from part A. At this point I'm not going to simplify that, and that's the final answer for part C. For part D, it says the function p is defined by p equals f of x squared minus x. Find the slope of the line tangent to the graph at p at the point where x equals -1. So what I'm going to do is find the derivative of p and then plug in -1. Chain rule. this isn't finished. You need to actually figure out the value here. You don't need to simplify arithmetic, but you do need to figure out what this is. So this is 1, that's 1, so 1 plus 1 is 2. Okay, I guess I didn't need to do that, but f prime of 2, we look up again, f prime is the slope at x equals 2, so it's not 0, that's the value of f. I need the slope of the line, and I already figured that out for a previous part of the problem. The slope of this line is negative 2. So f prime of 2 is negative 2, which gives negative 2 times negative 3, and as long as I came this far, I'm going with 6. You handle whatever algebra or arithmetic you're comfortable with. In this case, I felt comfortable giving the answer, so that's it. Okay, do you think you could try to solve the problem?
Yeah. So do I need to connect this to that?
I think you might need to color. You can connect that to that. So this is really a connect the dots kind of a problem.
No.
What is it then?
Does this look right?
Okay, well hold it up and show it to the camera, okay? Yeah, I think we're good to go.